now. All of you keep waiting. The next concept is rolling series. Oh, what is this? Just a minute. All of you keep waiting. Rolling series 1. So it is a combined motion. So whenever object is moving, so we all know that it is a combined motion. Rolling motion means it is having two kinds of motion. What is that, everybody? So combined motion of, yes please. It is a translation motion plus it is having another motion. What is that? It is only called as rotational motion. Okay. So this is also most important topic for NEET and as well as JEE. So there will be a question. Most of the years there will be a question in this. So we already know the types of motion we discussed a long back. So that's what translation motion and as well as rotation. So now, for example, let me take now, for example, I will take a circular object. So a disc or ring or whatever it is. So if I roll it, so let me choose a particular particle. Of course, there is a center. So the velocity having a velocity of the disc or whatever it is. So it is actually v velocity, it is traveling. Now it is started rotating. Rotating means what is that actually? Angular velocity omega. Now I am choosing a particle P. Particle P. This is what is the P. Let me take it as a disk. Everybody observe very carefully. Now, if it is started rolling or rotating on the surface, that is what I am taking a surface. So what will happen, guys? Only observe the particle P. Now this particle P will started rolling, and it will come at certain time, it will come to the ground. And again, it will start going. So like this, it will be keep on moving it is. Am I right, Mr. Prados? Rudresh, are understanding what I'm saying? So the particular point, if I take, it will be coming down and it will take rotation and again it will be started moving. Again, after traveling certain distance, suppose a body is reaches to here, again the point P will come to the same height, same position. Am I right, everybody? Do you all understanding? All of you? Yes, please respond. Can you hear me, everybody? So after certain time period, after certain time period T, again the point P will come to the same position. Now, if you observe here, the velocity and again, of course, it will be keep on rotating, angular velocity omega. Now, if you notice it here, to study this rolling motion, that is what translation to rotation motion, every particle in that will be keep on rotating and changing it. Of course, there will be in a translation motion as well as there will be in a rolling motion. So studying this motion is very, very difficult. If it is the translation motion alone, we can easily study. If it is a rotational motion alone, we can study. If it is a translation plus rotation, mixed motion, so it is very complex motion. So that is why if I am observing from here, suppose if with respect to ground, if I notice the point P, it is making a two kinds of motion. What is that motions, everybody? It is keep on after certain time period T, it is shifted to this position, means it is covering some distance. Yes, am I right, everyone? Please respond, all of you. Yes, Rudreswa? So that is what it is covering some distance. Yes. So what is the distance covered? Anybody can tell? This we all people know speed is equals to distance by time. So it is taking certain time period T to move from here to here. Means in the sense of, can you tell me distance is equals to, and velocity or speed of the body is V. So distance is equals to what will happen? Everybody? Distance is equals to what will happen? Velocity into, please respond. Velocity into time. So that will give you the distance. Now it is rotational motion. So will ask us to calculate the angular velocity. Now, if you notice it like that, I can choose a particle here. I can choose a particle here. I can choose a particle here. Every particle, if it is rolling on the surface, so definitely they will make translational motion as well as rotational motion. So actually, this is a very complex motion. So that is why we will use many simplest ways to study the rotational and as well as complex motion. So in this rolling motion, we'll learn first how to calculate the distance with respect to ground. That is very important. And with respect to COM. COM means what, guys? Center of mass. Understanding, all of you? Next, we'll calculate velocity. Next, we'll calculate acceleration. So this is what is about today's class. So mostly I'll try to finish it. So kindly focus it. So let us start with the first now. Let us start with the displacement. Now, if you notice it, if there is a disk or any kind of thing, so I will choose a point X. So after certain time period of T, so definitely you can notice it with respect to center of mass. Again, the position of the X will come to the same point. Am I right, everybody? Will you all agree with me? Please respond. All of you? Yes. And it is having angular velocity omega. And within a certain period of time, it is covered in the distance. Distance is equals to what is the formula? We have got it. Distance is equals to what? All of you. It is having a velocity v or speed v.
Velocity into time.
Equals to velocity into time. So after certain time period, it will cover a distance, yes. Again, it will comes to the same position. Means it is see that it is moving in a same position. Means it is a what motion? Translation motion. It is keep on moving and again it is coming to this position. So that is what we used to call it as rolling motion. That's what rotation motion. So both rotational plus translation, both we used to call it as rolling. We used to call it as rolling. Now in this rolling, we will learn how to calculate the distance. That is the first thing. So let us take now first question number 1. Let me understand from the question so that you all people can easily solve. So there is a disk, you can take it, whose radius is r. What is the radius of the disk, everybody? R. And having a velocity v. Okay, so it is started rolling on the surface. So now a person is standing on the ground. With respect to ground, we have to calculate it. Be very careful. So on having angular velocity omega. So now after traveling certain distance, so now the P came to exactly down. You can see now I'm taking a point. Okay, you can take it anything. So point is here. No, sorry. Point is here. So after traveling certain distance, the point P I have chosen, which is touching at the ground. So that is what from the center of mass, the distance what is to call everybody. That is only equals to what? The radius, COM. Clear, everyone? Now the question is, angular velocity is equals to V by R. They have given in the question. Time period is equals to pi by 2 omega. This is what is the question they have given. Okay. Now we have to calculate what is the distance travel. That is what is the question. Clear, everybody? Understanding? Anybody having any doubt? You can ask. So time period is equals to what? Everyone? Time period is equals to what? Yes, please. Pi by 2 omega. Okay. So let us calculate it and everything we'll do it now. So first of all, if you observe, distance is equals to, what is that, guys? Distance is equals to velocity into time. Okay. So now S is equals to V into time is equals to what is the given question they have given? Given question time is equals to what? Pi by 2 omega. Okay. And we know that omega is equals to what they have given? Omega is equals to how much? Yes, please.
V by R.
V by R. I will replace it. So S is equals to V into pi divided by 2 divided by V by R. So R will go up. So V will get cancelled. So can you tell me what is the distance equals to, everybody? R pi by 2. Understanding? R pi by 2. That is what is the distance. Are you clear now? Now, during this time period, what is the displacement it has been taken? That is what we have to calculate it. So we all knows that angular displacement. Linear displacement, forgot it. Angular displacement is equals to. Can you tell me? What is the formula angular displacement is equals to? Pradosh? Narayan? Angular displacement is equals to. Respond, Ra. Angular velocity into time. Because displacement is equals to velocity into time. So angular displacement is what? Angular velocity into time. Am I right, guys? Please respond. So omega into, so T is equals to pi divided by 2 omega. Omega will get cancelled. So what is the theta is equals to? Can you tell me? Angular displacement is equals to how much, guys?
Pi by 2.
Pi by 2. So pi by 2 means how many degrees? Everyone? Yes, Rudreshwa? 90 degrees. Means in the sense of it has been moved 90 degrees means exactly that point after pi by 2 angle, it will come to this position. Am I right, guys? Will you all agree with me? Everyone? Please respond. Everybody?
Yes, sir.
What is the angle here? What is the angle here? 90 degrees. So this is also R. So now we have to calculate what is the question is not calculating the distance. Of course, this is what distance? This is translational motion. We want to calculate now what is the distance with respect to ground. distance traveled by a point P with respect to ground, we want to find it. So how to find it? Let us observe now. All of you observe very carefully. Now, initially the point is actually at P point. Initially is at P point. Now, if you notice it, with making a theta angle, pi by 2 angle, it is moved to here. Now, can you tell me how much it is moved? Basically, it is at here. Now it is shifted to here. If I want to find the distance, can you tell me how to find it in x-axis? X-axis alone, you tell me, everybody. So everybody, can you tell me what is the distance it has been moved? Actually, this is the distance traveled. What is the distance traveled here? R pi by 2. Is it okay, Rudreswar? Understand? From here to here,
Yes, sir.
I've taken. So it has been moved R pi by 2 distance. Now it is not at this point. It is rises to this. Here it is their point. Means here it is. So what is this height? How much it is moved away? R. Am I right? Please respond. X-axis. So displacement of a point P with respect to ground, which is equals to x-axis. What is that? R pi by 2. And it has been not moved at the point x-axis. If it is at x-axis, it is at point P, but it is shifted to y. Now here above rises to this point. So how much it is rises actually from the x-axis? R distance it has been gone away. So that is what we can make it R pi by 2 minus R in the x-axis plus y-axis. Initially it is at point P. Now y-axis, how much distance it is traveled? Check it everybody. Y-axis, how much distance it has been went? 90 degrees has been made, it has been come to here. So what is that, everybody? Yes, please. How much height, y-axis, how much distance it is?
R distance.
R distance. Now, once again, I'll explain. Brothers, observe very carefully. Suppose it is at initial point P. Now, here it has been there. Now, actually, this point has to be here. But it reaches to 90 degrees so that it is been reaches to here. Am I right, everybody? Are you understand, Rudreswar, what I'm saying? Clear?
Yes, sir.
Whole distance is how much? How much we got whole distance? R pi by 2. R pi by 2. So that is what is the distance we got it. But you can see till here it is R pi by 2. Am I right or wrong? Everyone, will you all agree with me? Mr. Narayan, are you understanding what I'm saying? Clear? But it is not actually at this point. Now it is at this point. So from here to here, what is the distance? Can you tell me? What is the distance from here to here? From here to here, what rather, sir? This is center of mass, COM. What is the distance from here to here? It is also radius, R. Am I right? So now I want to distance x-axis. So x-axis means up to here only. Actually, it has to be here. If it is here, 2 pi by R. But it has been at this point. So how much distance it is less? R distance. So I want to get in x-axis means, so R pi by 2 minus R. Are you clear now? Brothers, understand? Rudreswar? Narayan?
Yes, sir.
Once again, I will explain. All of you observe. We are seeing an x-axis and y-axis. So now all of you check it, everybody. This is the x-axis distance in initial point P, and this is the final point P after certain time period. But now, because of angular momentum, the body has been moved 90 degrees and it is reaches to this point. Okay, everybody? Are you understanding, Amma? All of you? Now, this total distance, we got it. What is the total distance? This one, everyone? 2 not. R pi by 2. Okay. So if the body will stop at here, it is distance is in x-axis is R pi by 2. But it is moving a angular that's what, theta, which is equals to 90 degrees. And finally, it is at here now. So this is the total distance is R pi by 2, but the body is at here. Means I want to subtract this distance. That is what is the x-axis. Am I right, guys? Displacement in x-axis. Are you agree with me? Yes, please. All of you. So x-axis R pi by 2 minus R. That is what is the x-axis distance. Plus y-axis, tell me, everybody. If it is stuck here, what is the y-axis? 0. But it is not at here. It has been shifted to this height. What is this height, Rudreswar? What is the height? Which is
R.
R. So R j cap. That is the displacement of a particle with respect to ground is equals to R pi by 2 minus R into I cap plus R j cap. So this is what is the displacement of a particle with respect to ground. Anybody having any doubt, you can ask me. So once again, I'm saying So please very carefully observe. This is what is the position of the particle. Now, after certain time period of time, it has been came to here. Understanding? Then if it is came to here, the what is the total displacement? Total displacement of the body, everyone? 2 pi by 2. Sorry, r pi by 2. But it is making angular velocity omega, so that we have been found angular displacement is equals to, it is making pi by 2. Pi by 2 means 90 degrees. Means the particle is at here instead of here. So you can notice it. The total distance is r pi by 2, but the particle is at this point. Means we have to subtract this distance. Am I right, guys? In x-axis, please respond, guys. All of you. So in x-axis, this is the distance. It is less. So total is r pi by 2. And from here to here, what is the distance? That is what? Radius. So radius I will remove. So I'll get the x-axis distance. And y-axis, if the particle is at here, y-axis distance is 0. But the particle is rises here. Now it is. So what is that height? Which is equals to radius. So r j cap. I hope you all understanding. Anybody having any doubt, you can ask me. Are you clear, guys? All of you? Yes, please respond.
Yes, sir.
Yeah, any doubt, anybody can ask. Mr. Rohit, understand? Mr. Murali? That is what it is. Okay. Rudresh, any doubt, Ra?
No, sir.
Okay. So are you clear now? X-axis and y-axis, what is happening? Now, next question. So let us observe now. You can all notice it. So while you're practicing, you'll be familiar more even. So let me take now, there is a disk who is having a velocity at the center of mass is V and having a radius R. And angular velocity is omega. Angular velocity is omega. Now this is the point P. Please notice it very carefully. Okay. Now you can notice it. Angular velocity is a clockwise. So I'm just drawing like this. Angular velocity omega. So it is rolling on the surface. Rolling on the surface. So after certain distance, we don't know. After certain time period. So you all can notice it. Actually, particle has to be here, but it has at this point. At this point, that is the particle position now. So that is also we used to call it as what? From the center of mass, it is r distance only. Will you all agree with me, everybody? Please respond, guys.
Yes, sir.
Yes. So it is making a theta angle. That is what? Angular displacement. Okay. Any doubt for anybody? You have to respond. So now velocity is v. Now they are asking after time t. Please notice very carefully. After time t, find the displacement of particle P with respect to ground. That is what is the question. So anybody having any doubt, please ask me. So we all knows that. What is the displacement? Linear displacement, yes, and angular displacement, theta. What is the relationship between them? Can you tell me? S is equals to R theta. Am I right? Yes, please respond. That is what.
Yes,
now
sir.
you can notice it. So let I assume the displacement is theta. I have assumed that because it is stuck here. So means in the sense of it is a certain height above from the initial position. Have you checked it, everybody? Will you all agree with me? Can you able to imagine, Pradosh? This is what is the height it is. Okay. It is not at here. It is making a theta angle. So now they are asking, calculate the displacement of the particle with respect to ground after certain time period. That is what is the question. So you can imagine that it has been traveled. So let us see how to find it. Okay, everybody. Now, if it is reaches to here, like before question we can, but it is not reaches to that perpendicularly. Do you understanding? Everybody clear, Amma? All of you? So we all know
Yes,
that theta is equals to omega into t, angular displacement into t, or we can say theta is equals to omega t. Now you all people observe very carefully. Actually, from the center of mass I am drawing. Actually, the particle has to be here. This is the particle position, but it has been rises to here, and this is what it is making now. So I am assuming this is the theta angle. So theta angle means it is like a resultant force. You all people knows this is R. Then force is acting two different directions. Can you tell me, everybody? What is this become? R sin theta. And this will become what? R
cos
cos
theta.
theta. So parallel shift. Parallel shift I will make it. This R cos theta, can I imagine down? Everybody? Will you all agree with me?
Yes, sir.
All of you. Yes, please respond. So that is what it is. I assumed R cos theta here. So I'll just make it. So this is what is R sin theta. r sin theta, and this is r cos theta. Now, can you tell me in x-axis and y-axis, what is the displacement? Very carefully observe that height, this is what is r cos theta, and this is what is r sin theta. Now I want this height. Am I right, Rudreshwar? Can you able to observe everybody clearly? Please respond, guys. It is not at this point. So there will be a distance, height, distance graph. So can you tell me how to find it? So let me take now. So we all knows that displacement is equals to velocity into time. So displacement is equals to velocity into time. So it is moving with the velocity v and time period t. So now x-axis you tell me. So x-axis, what is the displacement? What you are finding? You all should tell me. All of you. So actually, if it will come here, see that total displacement is s equals to vt. If it is stuck here, it is s equals to vt. Now from here to here, what is the displacement is left? Anybody can tell? R
Sin theta.
Sin theta. That's all. So displacement of a particle with respect to ground is equals to total displacement is vt minus what will happen? Fastly respond. R sin theta into I cap plus next. If a particle reaches to exactly perpendicular, like before case, we can say it is r j cap, y distance, but it is not reached totally. See that? Actually, it is at somewhere at the middle. Here it is. So now, what will happen? Anybody can tell? This total height is, maximum height is r cos theta. Now the particle is at here. So I want to get it this distance. Can you tell me, guys, how to find it? Total is r cos.
Sir, R minus R.
Yes. So that is what is very important. Are you clear, everybody? So yeah. So that is what is everything. So up to here only. Sorry, I made a mistake. So now this distance is r cos theta, and this total distance is how much, guys? This total
R.
distance is r. So I want to get this small height. How to get it, everybody? R
R
minus
minus R plus.
r cos theta. That is very important in J cap. I hope you all able to catch it, everybody. Brothers, understand, Narayan? So r minus r cos theta into J cap. That's all it is. Over. If you are able to finish, understand this, it's very simple. So remember, up to certain distance, this is r cos theta. Then this total distance is r. So I want this distance. So what will happen? R minus r cos theta. Over. Understanding? Now you can replace. So particular is equals to vt minus r sine. So sine theta means what, guys? Theta means what? Everybody? Omega t. So omega t plus next r minus r cos. Theta means what again? Omega t. So that is how the displacement of a person with respect to ground. Be very careful. It is making both directions, x-axis and two-dimensional it is. So x-axis as well as y-axis. So that is what you have to see. I hope you all understanding, everybody. So now from this, I will form a relation. Be very careful. So if you want to find the displacement of a particle with respect to ground, first observe displacement of a particle with respect to center of mass. C means what, guys? Everybody? Center of mass. Displacement of a particle with respect to center of mass, which is equals to, keep it in mind, displacement of a particle with respect to ground minus displacement of a center of mass with respect to ground. Okay. Now, if I want this one, always we have to calculate this. So displacement of a particle with respect to ground is equals to displacement of a particle with respect to center of mass plus displacement of a center of mass. Center of mass with respect to what? Everybody. Center of mass with respect to particle. That's what it is. You can bring this one to this one. So it will become center of mass, displacement of a center of mass with respect to ground. That is what you have to remember. I hope you all clear, everybody. So this is very, very important relation. So if you want to calculate displacement of a particle with respect to ground, it is always displacement of a center of mass with respect to ground plus displacement of a particle with respect to center of mass. So please note it, everybody. I hope you all understanding. Anybody having any doubt, you can ask. Clear, guys? Mr. Rudreshwar? This is a relation first. It's most important relation which you have to remember it. Okay, guys? Clear, Amma?
Yes, sir.
Yeah. So please these both relations regarding displacement. Now, Displacement calculating. This is whatever the question they will ask, you have to calculate the displacement in such a way. So always in x-axis and y-axis, you have to see anywhere in the motion, rolling motion, anywhere you can calculate the displacement like this way only. Okay. Now coming to the velocity. So velocity, you have to imagine more. Just imagine. I will maximum. I will simplify it. So you have to feel like what is understand. So now let me take again. There is a wheel or a disc or something, a rotational body. So having a center of mass C, let me take, and having a velocity V. V is the velocity of a center of mass. So velocity of a center of mass remains what? It will be same constant. I'm taking a point P and I'm taking a point O. I'm taking a point M. I'm taking a point N. So we want to find the velocity of every point. Is it okay? For those, do you understand what I'm saying? So angular velocity is omega. So these many points I have chosen. We have to find the particle velocity of O, P, M, and N. So let us start now. Everybody understand. So velocity, we have to calculate it. So it is actually what? Mixed motion. Translation motion plus what motion, everyone? Translation motion plus rotation motion. That is what it is, a rolling now. So let us find now first velocity of this particle of O. Okay, so particle O I am taking now. So keep in mind, whatever the velocity of center of mass, same velocity is present for every particle. Will you all agree with me? In translation motion, everybody, please respond. In translation motion, whatever the velocity of a particular particle, every particle will be having the same velocity. Is it right or wrong? Please respond, all of you. Yes?
Yes, sir.
Yes. So now you can see, I am observing only particle O. Everybody make attention now. So particle O is trying to move in this direction, translation motion, and rotational motion also in the same direction. Do you clear, everybody? So velocity of the particle O is equals to, so we all know, so I can say is velocity of center of mass, both are in same direction. So plus what is the theta here, angular, we all people knows that theta displacement is equals to what is, sorry, velocity is equals to what is the relation? Well, rotational motion, what is the relation? Velocity is equals to rotational motion, guys. V is equals to R omega. So velocity of a particle O is equals to velocity of center of mass plus rotational motion, velocity of rotational motion, R omega. That is what is very important. Next, velocity of particle P. This is very important. Be very careful now. So you all notice it. Particle is trying to move like this, translation motion. This is what is the translation motion. But rotational motion, what? Like this rotational motion is coming. Means rotational motion acting like this direction. Is it okay, brothers? Can you able to catch that, Narayan? Understanding? Rotational motion is acting downward direction. So, can you tell me, this is velocity in translation motion and velocity in rotational is R omega. So, both are perpendicular to each other. So, that what will happen? Velocity, it will act what? Net velocity will act in between them. That is what? V net. This is for particle P. Are you understand, Laksha? Princey? That is what.
Yes, sir.
So acting rotational is velocity is downwards. Translation velocity is in straight. That is what? Center of mass. So V net is equals to, what is the formula? Particle P. So V net is equals to, we all knows that, guys, which is equals to square root of velocity of center of mass whole square plus rotational motion
R
velocity
omega whole square.
square. That's all it is. Okay, that is what is very important. Next, velocity at point P. Very carefully observe. Now see, rotational motion is trying to go like this. Means rotational motion is acting like this way. But translation motion is what? In this way. Both are perpendicular to see. Both are parallel and opposite to each other. So that what will happen? This velocity is velocity of center of mass. And this velocity is R omega. So can you tell me what is the net velocity at point M? Net velocity is point M. This is center of mass and this is velocity of center of mass, which is equals to this is omega. So body is moving forward. So this is positive and this is what? Everybody. Yes, please. Negative. So that what will happen? Anybody? So net resultant force at the M, which is respect to ground, is equals to velocity of particle m with respect to ground is equals to velocity of center of mass opposite, guys. So minus or plus or? Minus rotational motion. That is what I have to remember. Clear? Rudreswar, understand? Pradosh?
Yes, sir.
Yeah. Now n particle, you all tell me. At particle n, you should tell me. I won't say, you only tell me. So this is the particle n. So the translation motion is like that. That is equals to center of mass, velocity of center of mass. Now rotational motion, can you tell me? It is acting what direction? Rotational motion, what direction it is acting? Everybody. Rotational motion, what direction, guys? Upward direction. Are you clear, everyone? So that net resultant force, the net resultant net velocity will act in this direction. That is what V net. So V net is equals to what? Anybody? V net is equals to velocity of n particle with respect to ground. That is what V net is equals to. What will happen, guys? Velocity of center of mass whole square plus rotational motion square. That is what you have to remember it. Now, are you clear, everybody? Now, can you tell me what is the velocity of a C? Velocity of a C. Velocity of a C, there is no kind of displacement position. It remains constant. So, can you tell me what is the velocity of a C? Everybody. Center. Velocity of a C is equals to what? Which is equals to velocity of
Center of mass.
velocity of center of mass. Are you understand, everyone? So this is the most important concept. So velocity, be very careful. Here particle O, if I have taken, translation motion also in same direction, angular velocity also in same. So that angular velocity and same and translation velocity both are in same. So that the velocity of particle O is equals to velocity of center of mass plus r omega. Okay. Next, but this particle you can see, it is trying to move like this. Rotation will be downward direction, but the body is moving forward direction. So both are perpendicular to each other. This particle and this particle. So that is what we used to say is that. So both are perpendicular. So net resultant force, net resultant velocity will act in between them. So now here also net resultant velocity will act in between them. So we all people knows how to calculate it. I hope you all understand, everybody. Clear? 4 different places. And velocity of C. Velocity of C is not going to change. The position is always remains constant. So which is equals to velocity of center of mass. Okay. Any doubt? Ask me. Prados, clear? Isali,
Yes, sir.
Kadri? That is what it is. Anything doubt? Please let me know. Mr. Narayan, understand? Pradeep?
Yes, sir.
Yeah. So proceed, please. Sai Karthik, understood? Princy?
Yes, sir.
That is what it is. Now, I will give you the question. So everybody's will give you the time will be given and you have to try that also. So now let me take, now there is a question, please write. There is a circular motion. Let this you can take it. So particle point B, I am taking point A, I am taking point C, I am taking. So who's having a velocity? V is equals to center of mass 4 meter per second, having a radius 1 meter. What is the radius, everybody? 1 meter. And angular velocity is equals to 3 radians per second. Okay. Now question is, find the speed of ABC. Note the question. Later we can solve. And as well as, like I am putting mod. Mod means what? We have to arrange them irrespective of plus or minus. You have to arrange them in increasing order. That is what is the question. Okay. So everybody try. Meeting is going to end. Join back and we'll continue. Increasing order, you have to arrange it. So let us see, everybody, who will solve first. Make it fast, everyone. Try. If you try, it is very simple. So just what we studied, the concept, if you apply over. So find velocity of A fastly, everyone. Velocity of A, see that. The body is moving, trying to move forward. That is what velocity of center, which is equals to 4 meter per second. But rotation will be in what? Opposite. That is what? Angular velocity, which is equals to r omega, sorry. We have been done. What is that? Theta is equals to r omega. Am I right, guys? Please respond. All of you. So r is 1 and omega is 3, which is equals to 3 meter per second. So can you tell me what is that? Both. This is 4 meter